Marvin Herndon's work is very extensive. It's going to take me a long-ass time to go over all that stuff. Let's be honest here. So I'm just going to pick one certain thing that I've noticed differences between stellar metamorphosis and his hypothesis. Let's go ahead and spell that all out. Alright, we have two main methods for planet formation that are published inside of a lot of research. You have the first one, condensation at very high pressures, hundreds to thousands of times higher than 1 atmosphere. And 1 atmosphere is Earth's pressure at sea level. It's what you breathe in when you're standing at sea level. If you're in Denver, Colorado, that's not exactly the case, it's a little lower. Number 2, condensation at very low pressure, which is 10 to the negative 4 atmospheres. I think I did my scientific notation correct on that. 0.0001 atmosphere. That's many thousands of times lower than 1 atmosphere. Okay? Herndon has condensation of the Earth at very high pressures. This makes sense. Okay? Because he has gas giants forming rocky objects in their center. Okay? This is spot on. Okay? The condensation to form the structures that we see, such as mountain ranges and a lot of the things that we see in geology, could only have been formed, as well as the core of the Earth itself, under very high pressures. You don't make something like that with low pressure. The Thompson structures inside of the core, which we have evidence of in asteroids, falsifies the low pressure model, falsifies this. As well, the establishment has condensation at very low pressure. I think the reasoning behind that was, you have outer space, it's very low pressure, it's like a vacuum, and then this cloud of gas gravitationally collapses on itself magically. Well, gravity doesn't do that. Clouds of gas don't do that. They're never going to condense. A rocky-like object like Earth is not going to condense at very low pressure. Okay? It needs very high pressure to form the crystalline structure known as rocks and minerals, and even the core of the Earth. So we can just toss that out. The problem with Herndon, though, is that he doesn't realize that the star does start out at very low pressures. Okay? What actually happens is that after the star is born, and it's about the sun's age, about maybe 30 to 65 million years old, you have condensation at very low temperatures, pressures. That's what the sun is, very low pressure. Okay? But then what happens is the pressure increases very rapidly as it gravitationally collapses. The star will cool and shrink and gravitationally collapse on itself. So we'll go from very low to very high temperatures, and then you can include Herndon's argument to where it forms the rocky ball in the center, forming all the rocks and minerals that we see, and the core of the Earth and the mantle and all that good stuff. And then it drops back down to low again in the atmosphere, because the atmosphere gets ripped away by hotter host stars after it's been transferred from solar system to solar system to solar system. All the objects in our solar system are adopted. Everybody should know that. They were adopted by the sun. And they're all different ages. And I put right here, here's pressure. You start at a very high pressure in Herndon's model. Notice how he doesn't have a formation model for gas giants. So we can put a big question mark there. He gets the end correct. But the beginning, where stellar metamorphosis covers, he doesn't really go over that, because he keeps stars mutually exclusive of planets, which is the essence of stellar metamorphosis. The star is the young planet. Establishment, we've already gotten rid of their nonsense. They have low pressure begetting low pressure. Nothing's going to form in that. Their models are complete nonsense. With stellar metamorphosis, the low pressure starts out really small, or the pressure starts out really low, right? comes up as the star evolves, and it pressurizes the interior, and then the atmosphere gets ripped away, and it goes back down to lower pressure again. Notice how it's similar to a bell curve. Okay? I don't know if that's really significant, but I just thought after my statistics class, about 5-6 years ago, it looked pretty similar. So essentially, it's not 2 methods, it's 3. Either you can understand this happens, which does, and realize that it's forgetting the beginning. You can do this and agree with all the pundits and so-called experts, even though it's nonsense. Or you can combine Herndon's understanding with the fact that we know that stars are very low pressure when they're young. Now, I also want you to know that when you read articles on the sun and its pressure, like the NASA fact sheets and things like that, they have the core of the sun as being extremely high pressure. I think that's very problematic. I think that begets more ad hoc hypothesis, which then beget more ad hoc hypothesis, and before you know it, the sun's a fusion reactor and nobody knows what they're doing. I think there's something very strange about electrical interactions in outer space and magnetic interactions, and I also think that there is an aspect to nature that we don't fully understand yet when it comes to gravitation. So essentially, the sun might not be as massive as it's calculated to be. Maybe there might be a property of plasma that interacts with other older stars that causes it to appear to have a lot of mass, therefore begetting the concept of having really high pressure interior. My readers should know that I believe young stars like the sun are mostly vacuumous and they have membrane-like structures coursing through them like a bubble bath, basically. But anyways, I wanted to go over Herndon's idea. Let's go ahead and erase this real quick because there's something else I want to add in this video. Remember the Hertzsprung-Russell diagram? You had your color spectrum, then you had your magnitude, high magnitude, low magnitude. As if you can see it, okay? It's bright. Bright, dim. And you had your different colored stars. And the diagram went up here, real high ones, cooled, shrunk, moving along basic evolutionary path. Now, what Herndon does is he does this. Remember when I showed you the rocky objects were down here? And the gas giants were up here? And the stars that establishment calls are up here? Well, establishment science, they're dumb. They don't realize that the stars move like this, and they cool and shrink and die, so we can just ignore them. And it also means they don't understand that gas giants cool, just like in Herndon's model. They cool, and they pile on all that material to make a rocky body in their centers. This is beyond establishment as well. They don't understand this. Here to here. This is what Herndon did. But what stellar metamorphosis does is connect here down to here. Means the star is the planet. Now that's one thing I haven't read anywhere in Herndon's model, and that's the whole point of the discovery I made. Because when you look up at stars at night in the night sky, okay, you're looking at exoplanets. But hopefully people can understand what that really means. Herndon connects gas giants to rocky worlds, and I've already done that with stellar metamorphosis. Became obvious to me. But when I connected stars, okay, it was like, wow, I could see all this stuff. You can see all of it. And when I read scientific articles now, I can see where everything is wrong. It's pretty incredible, and hopefully I can share this understanding with as many people as possible, because I believe it's worth paying attention to.